Okay, practice test number 1. Your numbers may look different than mine when you do your practice test, but they should be the same types of problems with just different numbers. So just be aware of that. Okay, but it should all be the same types of problems. And so let's look at number 1. Find the missing terms in the sequence and determine if the sequence is arithmetic, geometric, or neither. Okay, so here, it looks like our pattern is we're subtracting 2 every time. Okay, so 3 minus 2 would be 1, 1 minus 2 would be -1, -1 minus 2 would be -3, so -3 minus 2 would be -5, and then minus 2 would be -7. So our rule here that we're subtracting 2, you don't have to write that down, but we do have to use that to determine if our sequence is arithmetic, geometric, or neither. Okay, so here, since we're subtracting some number over and over again, that means this is an arithmetic sequence, or an arithmetic sequence. Okay. Let's look at number 2. Number 2 says find the missing terms of the sequence. Same thing, and determine if it's arithmetic, geometric, or neither. Okay, the numbers are kind of big, so it's kind of hard to see to start with, but it looks like when we go from 320 to 80, we're dividing by 4. Okay, and you can check that with the bigger numbers with your calculator if you need to. So if we're dividing by 4, then the next number, 80 divided by 4, would be 20, and then 20 divided by 4 would be 5. So those would be our next two numbers. And since our rule is that we're dividing by 4 every time, then this will be a geometric sequence. So if you're adding or subtracting some number over and over again, it's arithmetic. If you're multiplying or dividing by some number over and over, it's geometric. And if you have some other pattern, it's neither one of those. Okay. Look at number 3. We got the animals in the field here, and we got goats and ducks on this one. So we've got a total of 33 animals because it says we have 33 heads, and we're trying to end up with a total of 94 feet. Okay. So we're assuming all the goats have 4 feet and all the ducks have 2 feet. Okay. So again, on these, it's just trial and error is, to me, the best way to work these. So we got to have something that totals up to 33. So I'm thinking maybe we've got 11 ducks and 22 goats. And then I'm just going to check it. Okay, so because that 11 plus 22 is 33. So then if we have 11 ducks, that means we've got 22 feet here. And if we've got 22 goats, that means we would have, 88 feet there. And that's going to be too much, right? Let's see. 22 plus 88 gives us 110. So we've got too many feet. I've got too many feet. So to reduce that, I'm going to change some of my goats to ducks. Okay, so let's try again. Maybe let's do, we can skip up a few, I think. So maybe let's try 14 ducks. And then let's see, 33 minus 14 will be 19 goats. Let's try that one. So this will be 28 feet. And then 19 times 4, what is that? That's 76. That's still going to be too many, but let's see how far off we are. So if we add those together, 28 plus 76 equals 104. Okay, so we still got to go down on our number of feet quite a bit. So we need to increase our number of ducks. So let's see, maybe we'll do 18 ducks. I'm just guessing. Okay. So if we do 18 ducks, then 33 minus 18 would be 15 goats. If you're really close, you can kind of figure out how many you need to change, but here we're just kind of guessing. So that would be 36 duck feet, and then 60 goat feet. So that's really close. All right. If I add those together, that's going to be 96 feet. So it looks like we just got to adjust by 1 here. So I'm going to go up to 19 ducks. And so if we go up to 19 ducks, 33 minus 19, I should have kept up with it. There's 14 goats here. So this would be 38 duck feet. And 14 times 4 is 56 goat feet. If we add those together, 38 plus 56, that equals 94 feet. Okay, so that's what we want. We want 94 feet, so we need 19 ducks, 14 goats, just trial and error there. Sometimes you get lucky and your first guess is better and you don't have to work as hard. Sometimes you have to make several guesses before you get close. Okay, on to number 4. Number 4 says write the set using the roster method. The roster method is where we list out all the elements. So we're still going to call it set C. And then we've got to have the curly brackets. Okay, so C equals our open curly bracket. And we want the y's such that y is between 12 and 26. And y is an even number. And it says or equal to on our inequality. So we're going to start with 12 because it's even. And then work our way up to 26. So the next even is 14, and 16, 18, 20, 22, 24, and the last one is 26, and then close our curly bracket there. Okay, so that is the roster method version of that set. Okay. Number 5 tells us to determine the cardinal number of the set, and if it gave it to you in notation, it would look like absolute value, right? The cardinal number. So the cardinal number of our set here is just how many elements it has, so we just count them. 1, 2, 3, 4, 5, 6, 7, 8. This is really a vocabulary problem. Okay, it's not really have any calculations or anything to do there. Number 9 says use the given sets to answer the question, is P equal to Q? Why or why not? So remember, if two sets are equal, that means they have exactly the same elements in each set. Okay, no extras in any of the sets. They have to be exactly the same. Okay, remember there's another notation that's similar that has a squiggle over the equal sign that's called equivalent. So for two sets to be equivalent, that would mean they have the same number of elements. On this one, we're looking for equal so that they have exactly the same elements. So on this one, our answer, we've got maple, elm, pine, birch, cedar, and beech. And then Q is the set of X's such that X is a type of tree. Well, there's other types of trees other than the ones in set P, so they're not going to be exactly the same. Q is going to have more elements in it. Okay, so we're going to say no because set P has fewer elements than set Q because maybe an oak tree, okay, would be in there, or a willow tree. Those could be in Q, but they're not in P. So Q is going to be bigger. Okay. Number 7. And I hate it when they use the whole alphabet on these, but we'll work with it. I'll show you what I do. This one says if A equals GRID, and the universal set is all the letters in the alphabet, find A complement. Okay, so if we're going to find A complement, remember that means we want all the elements that are not in A. Okay, we're going to have our curly bracket. So what I do on these when it gives me so many elements in the universe is I'll cross out the ones in A. So I don't want G because it was in A. I don't want R because it was in A. I don't want I because it was in A. And I don't want D. And then all the rest of those elements are going to be in A complement. So what have I got left? We've got A, B, C, E, F, H, J, K, L, M, N, O, P, Q, S, T, U, V, W, X, Y, Z. I hate it when they give us such a big set there, but it's a bad bracket. But that's A complement. All all the letters that are not in set A. Okay. And number 8 says list Y complement using the roster method. So again, it's just giving us a picture this time. We want Y complement, so we want all the numbers that are not in Y. Well, here's our set Y in this red circle. So we don't want these. Everything else is going to be in Y complement. So it doesn't matter what order you put them in. Okay, just make sure you get all of them in there. So we got 5, 8, 10, 23, 36. Then we've also got the ones on the outside, 14, 25, 29, 41. Okay, everything that's not in Y. Okay, number 9. It says set L contains the top girl names of 2014 according to Baby Center. If L equals Sophia, Emma, Olivia, Alva, Isabella, Mia, Zoe, Lily, Emily, Madeline, Madison, Chloe, how many proper subsets does L contain? Okay, so we need to count how many elements we have in set L. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements here. So for proper subsets, it's going to be 2 to the n minus 1. So n is 12 because we have 12 elements. And then if we go to our calculator, 2 to the 12 is going to be a big number. It's 4,096. We got to do minus 1 because it says proper subsets. So we have 4,095 proper subsets. Okay. If it just said subsets, it didn't say proper, then it would be 4,096. Right? But when it says proper subsets, you've got to subtract 1. Okay. All right. Number 10 says use the given sets to find A union B. Okay, so if we're finding A union B, what's that set going to be? Well, the union, okay, if we have a union, then an element is going to be in the union if it's in either one of the other sets or both. Okay, so 1 is in A, so it's going to be in the union. 2 is in both, so it's in the union. And we got 3, 4, 5, 6, 7 is in A, 8's in both, 9 is in A, 10 is in B, and 12 is in B. So we're just combining the two sets together. You don't have to put them down twice. Okay, just having them in there one time is good enough. So the union, we're basically putting the two sets together. Okay, so an element that's in either set will be in the union. Okay. Number 11, we're going the other way. This time it says find the intersection of A and B. So for the intersection, the only elements that are going to be in the intersection are the elements that are in both sets. Okay? So like here, 3 is not going to be in the intersection because it's only in B. But 5 will be in the intersection because it's in both. Okay? So 5 is in here. 6 is not in both. 7 is. 8 is not in both. 9 is. 10 is not in both. 11 is. And 13 is not in both. So there's our intersection. 5, 7, 9, 11. Because those are in both sets. Okay. Right, number 12. Same ideas here. We've got 2 steps to take. Okay. So the first part we want to do is we want to do the parenthesis part. So we want to do B intersect C. Okay, so we want the elements that are in both B and in C. So let's look. C is in there. O is in both of those. U is not. R is not. T is not. E is not. S is not. Y. Oh, S is. Y is not. Okay, so there's B intersect C. So now we're going to take this new set and we're going to do the union of that set with A. So we're doing the union of A with this new set we just made, B intersect C. Okay, so we're looking at A, and we're looking at B intersects C, and we're going to do the union. So for sure, we got all the letters that are in C. And then we need a C that's already in there. We need an O that's already in there. Finally, we need an S because that's in B intersect C. Okay, so that would be our fancy set we made there. Okay. Number 13, we got to draw a Venn diagram, or it helps to draw one anyway. You can use the inclusion-exclusion principle. It says we got a survey of 600 volunteers, 412 were tour guides, 325 were retirees, and 235 of the tour guides were retirees. How many of the 600 surveyed volunteers were tour guides or retirees? So, it helps to make a Venn diagram here. So we'll have tour guides over here, we'll have retirees over here. Start in the middle. It says 235 were both. Okay. And now it says 325 were retirees. Well, we've already got some of those in there, right? So we've got to do 325 minus the 235 that were both. And we'll get 90 that were only retirees. And then we've got 412 that were tour guides, but we've got to do 412 minus the 235 that were both. That gives us 177 out here. And then you could figure out how many were out in U, but we don't have to on this problem. So the question says, how many of the 600 surveys volunteers were tour guides or were retirees? Well, since we've got our Venn diagram, it's easy. We just do 177 plus 235 plus 90. How many do we get there? Get 502. And so some of the people in the survey were neither one. So we have 502 that were one or the other or both. Okay. What's next? Number 14. Ask us about mathematical statements. Remember, a mathematical statement has to be able to be given a truth value. It can't be an opinion. Okay. And it can't be a paradox. Okay. So this one says, which one is not a mathematical statement? A says, I'm driving 5 miles an hour over the speed limit. Well, that can be either true or false. B says, whole milk has 146 calories per cup. That could be true or false. C says, my boyfriend was born in Atlanta. That can be true or false. D says 23 is the coolest basketball jersey number. You might agree with it, but that's an opinion. All right, so this one is the one that's not a mathematical statement. This is just somebody's opinion. You can't say it's true or false. It's just an opinion. Okay. Number 15 says, use the letters given to express the given compound statement in symbolic form. So we want to make the statement, I like green eggs and ham. Okay. So the first statement is, I like green eggs. That's statement M. And the second statement is, I like ham. We want to say both of those things. We want to say, I like green eggs and I like ham. So we'll put our and symbol in between those two. So that is, I like green eggs and I like ham. All right. We got that one in symbolic form now. 16 is going the other direction. It gives us, sorry about that. It gives us the symbolic statement and says express it in words. So this first part here says squiggle A, so we've got to negate A. A is I have a headache. So if we negate that, we could say I do not have a headache. Oh, I do not have a headache. And then the next symbol is or. And then statement B is I am tired. So our compound statement is I do not have a headache or I am tired. Okay. Just watch out for that negation. Okay, number 17, we got to complete a truth table. All right, so looking at the truth table, we're going to take it one column at a time. I'm doing this squiggle A column first. So what I'm going to do there is I'm going to look at the value in A, and since we're doing the negation, I'm going to flip it. So it went from true to false, goes from true to false, and it goes from false to true, and from false to true. Okay. Now I want to do the same thing for B. I want to do the negation of B. So it'll go from true to false, from false to true, from true to false, from false to true. Okay. And then now this says I want to take the squiggle A column, the squiggle B column, and join them together with AND. So for AND, both of the statements have to be true for that AND statement to be true. So here we've got false, false, that's going to be false. We've got false, true, that's going to be false. True, false, that's going to be false. And then true, true, that's what we're looking for. That one is going to be true. Okay. There's our truth table. Number 18. Given the statement, if I'm buying strawberries, then it is summer. Is if it is summer, then I am buying strawberries. The converse, inverse, contrapositive, or biconditional for this statement. So what's happened on this one? We've just switched the order, right? Instead of starting with I'm buying strawberries, we end with that. And instead of ending with it is summer, we start with it, right? So we have gone from if P, then Q to if Q, then P. Okay, so we've switched the order. Okay, so if we switch the order, which one is that? Okay, that is the converse. Okay. The inverse is if we negate both sides. The contrapositive is if we switch the order and negate both sides. And the biconditional is if it says if or only if and only if. Okay, so this one, when we just switch the order, has the converse. Look at this one. This one says which is the inverse for this statement. So if we want the inverse, we've got to negate both sides. Okay? So it says if I am sick, so if we negate that, we would say if I am not sick, then the house is messy. If we negate that, well, then we would say then the house is not messy. Which one says that? It says, I believe that is C. If I am not sick, then the house is not messy. So this one would be the inverse. Okay? This one says if and only if, that would be biconditional. Okay. This one switches the order, says if the house is messy, then I am sick. That's the converse. And this one says if the house is not messy, then I'm not sick. That would be the contrapositive. It switches and negates both sides. Okay. Number 20 says find the contrapositive. Okay, so if we're going to find the contrapositive, what do we got to do? Well, first we've got to switch. Okay, so if we just do the switch, we get this. But then we got to negate both sides. Okay, so we could write that like this. But you can think about them kind of like negative signs when you have two squiggles that cancel out. So here our contrapositive would just be if Q, then P. It's our contrapositive. So we switch the order and we negate both sides. This is the contrapositive. Okay. 21 says use De Morgan's laws. So you can think about this. What we're doing is we're distributing this negation sign. Okay. But when we do that, a really important thing to remember, and that's the point of De Morgan's laws, the really important thing to remember is that when we do that, we have to flip the symbol in the middle. So this will change to AND. Okay, so we'll end up with squiggle, squiggle, P, and squiggle Q. Okay. But since we've got two squiggles on the left, they cancel out, and we can just leave it P and squiggle Q. Okay, P and the negation of Q. All right. Just remember to flip that sign in the middle. Okay, last one here, and it's another guess and check or trial and error problem. Postage stamp problem. We got to get to $1.94 in postage. We're using 46-cent stamps and 7-cent stamps. Okay. So what I'm going to do is I'm going to do 1.94 divided by my big stamps, 46 cents, so 0.46, and that's 4 point something. So I'm going to try using 4 46-cent stamps. I'm going to check and see if that works. So if I do 4 times 0.46, that gives me $1.84. And $1.94 minus $1.84 is going to be 10 cents. There's no way I can make 10 cents out of 7-cent stamps. So I can't use 4 of the big stamps. So then I'm going to go down and try 3. Okay, so if I do 3 times 0.46, what does that give me? That gives me, sorry, I punched the wrong number. If I do 3 times 0.46, that's going to be $1.38. So now if I do 1.94 minus 1.38, I get 0.56. And if you divide that by 0.07, and we're going to get that 8 will work. So 8 times 0.07, 56 cents. And if we add those together, 56 cents plus $1.38, we get $1.94 like we want. Okay, so we're going to use 3 46-cent stamps, 8 7-cent stamps. Okay. Have any questions, let me know.